them without a hard or a soft fork to Dogecoin specifically. And as you'll see, this kind of created a perfect stage for us to build a proof of concept for TrueBit. So the outline of this talk will be first getting coins from Dogecoin to Ethereum. So the process of sending these coins, proving to that Ethereum relay contract that you locked them, and minting the WOW tokens. And then the second part of the talk will be around what happens when you burn these WOW tokens and receive Dogecoins on the original chain. So the Doge to Ethereum peg. So fundamentally, what does this relay contract on the Ethereum side need to do? You just sent a Doge transaction locking up your coin, so you need to prove to this contract that that actually happened. So you need to give it a Merkle proof of this transaction rolling up into a transaction Merkle root. So the contract rolls up that Merkle proof. It's like, yes, it checks out. But more importantly, it needs to verify that that transaction Merkle root isn't a real Doge block header. Because otherwise, you could just give it a proof for something that didn't happen on the canonical Doge chain. So what this thing needs to do, if you see this person who's kind of a submitter, similar to BTC Relay, is passing in information into the smart contract, which is the purple square. And they could relay proofs of transactions. But more importantly, they need to actually relay block headers, Doge block headers, to this contract. And so anyone's welcome to submit a block header, which is really just a data structure with a height, a timestamp, a difficulty, transaction Merkle root, and a proof of work field. And the contract needs to verify if the header is legit. So it does a bunch of calculations. It checks that the height is calculated correctly, the timestamp falls within the allowed range, the difficulty makes sense. Most importantly, it checks the proof of work. And that's when things get tricky. So Dogecoin's proof of work is the script hashing function. Dogecoin was a fork of LuckyCoin, which is a fork of Litecoin. And script was chosen specifically because it's memory hard and computationally intensive to calculate. So what you do as in standard proof of work, you have all these fields that you don't have any control over, such as the transaction Merkle root, the height, these things, and then there's a nonce that you do control as a miner, and basically you have to pass these through the script hashing function to create a correct block hash, and the relay contract needs to basically verify that that hash was correct, i.e. take those plaintext fields, pass them through that function, and see if the hash was actually calculated correctly. The problem here is that this simple hashing function doesn't fit within the Ethereum gas limit. So when people had the idea of building this bridge, you can see here it's from 2 years ago, and Vitalik actually posting this, where people were experimenting with different ways. And what he ended up doing was actually splitting this calculation into 118 different transactions, where basically the contract would just like move up, do a bit more of the script hash, save its state, do a bit more, save its state, and it's really not feasible. And script specifically under the hood, how it works is 2050 steps of the salsa 20 hash function. So basically the inputs come in, and then there's 2050 steps where the output of each step is fed into the next hash function. And specifically the second half of the second 1,025 of the steps refer to data that was generated in the first 1,025. So that's what makes it memory hard. You need to actually keep all that data around. And that really makes this complicated to be done on-chain. So as the legend goes, Alex Van de Sande kind of created a DAO bounty to incentivize people to go and build this thing. People donated a few thousand ETH that at today's prices is worth $1.5 million. And about a month ago, TrueBit in collaboration with Oscar Ginsberg and CoinFabric actually demonstrated this on the Rinkeby testnet. And we got part of the bounty, which we're fully putting towards this open source art project, which is its own story. So basically, we're not taking any of the money for ourselves because this was such a cool community effort. We're giving the whole thing back towards creating a massive physical version of this bridge, which will be in Central Park, and it'll be like a physical blockchain, and it's a it's its own whole story. So you should go. There's a write-up of it on the TrueBit Medium blog. You can go check out. So we've talked more before about how the Doge to Ethereum peg works. So I'll just cover it quickly, and then we'll move to the reverse peg. So this is kind of the architecture of the smart contracts. At the top, you can see the Doge blockchain. And anything below that line is happening in Ethereum. And there's really two participants in this protocol. There's the person at the top. It's really hard to read this, but the person at the top is providing Doge block headers to the purple rectangle, which is the Doge relay contract. And the Doge relay contract then needs to verify the proof of work, but it can't do it itself. So it basically kicks out to this set of contracts on the left, the two green boxes, which comprise a specific version of the TrueBit protocol. So the second participant in this protocol are these people on the bottom here, which are the verifiers. So within the TrueBit protocol, basically, anyone can submit a computational task. Anyone can solve that computational task, and then the verifiers are watching that solution, and if they disagree, they can basically challenge it. And each of the solver and the challenger need to have stake deposited into the contract, and in the case of a dispute, basically, this verification game begins, which generally, it's the way the TrueBit protocol works, so it derives insight from the fact that both the solver and the challenger agreed when the program started. So at step 0, both of them, when they started running this, they had the same program, the same inputs, and the blank virtual machine. And after they ran through the entire program, they obviously disagreed on what the results were, because they got different answers. So the challenger basically queries the solver for their state at the halfway mark of the execution. So in the case of script, since it's 2,050 steps, it queries the solver for its state at the 1,025 step. And that state is literally a Merkle root of the VM that the solver was running of the entire state. So in the generic TrueBit protocol, it would be a WebAssembly VM where we take the linear memory, the stack, the locals, and kind of put them into a Merkle tree and create a single root from it. In this case, it's the variables that are used within the script hash function. So the challenger plays this interactive challenge response protocol with the solver until they resolve on one final step, the first step of dispute, which then runs on-chain inside of this, the smart contract on the left here, the green one. And so this was a specific implementation of the TrueBit protocol, which allows us to run 99.9% of the time run the script hash fully off-chain and get the result back on-chain. In the case of a dispute, you only run one single slice, one single salsa 20 hash on-chain. And then the green contract in the middle makes a call back to the Doge relay saying, yes, this hash is legit. The contract adds that block header to its list of known block headers, and then all is good. So that's kind of it's a relatively complicated protocol, and we have a more thorough demo of it online if you look it up. So just to kind of close the loop, what this means is the Doge relay contract has a way, now has a list of the canonical Doge block headers. So anyone was welcome to submit headers to this. It checks that the proof of works are correct, and it keeps track of the heaviest chain. You know, it allows some timeout for the heaviest chain to emerge. And then, say, when you're 100 confirmations deep, then someone can submit a transaction Merkle proof showing that their Doge transaction actually occurred and that they locked up their tokens, at which point the Doge relay contract makes a call to the red square down there, which is the WOW ERC20 token contract, and mints an equal number of ETH Doge tokens for that person. So this is the forward peg, Dogecoin to Ethereum. So the Ethereum to Doge peg. So this one's more complicated. So, I mean, it's complicated in its own way. So if you recall, basically, sidechains have been a topic of discussion for a long time. Blockstream sidechains paper came out in 2014. Various protocols are exploring that. Cosmos, Polkadot, BTC Relay, all projects that are trying to build sidechains and link them to a kind of root chain. And, but in this particular problem, it's actually more complicated than most of those constructions. The first issue is that Doge is a UTXO blockchain. So you don't have smart contracts. Basically, all you have are a set of unspent transaction outputs, which you can provide with some data to unencumber them and spend them in some way. The actual programming language that you're working with is a fork of Bitcoin script. So you don't have the Turing-complete VM that we have in Ethereum. You can't keep state between transactions, so all the data that you pass in needs to come in at once and then either enable you to spend that UTXO or not. And Doge is an existing chain, so whatever we come up with needs to be practical. It can't really involve a hard or a soft fork. So we originally talked with the two main Dogecoin developers, and Dogecoin is merge mined with Litecoin, so it's like even more complicated than a standard blockchain to fork. You need to convince a whole community of miners that are outside of the ecosystem, exchanges, wallets, existing tooling. So you really want to be able to build this without modifying. So we started coming up with ideas. Right off the bat, the most ideal idea is to create something that mirrors the Ethereum side. So when these WOW tokens were burned, you can see that burn event or that transaction sending the coins back to the relay is itself linked to an Ethereum transaction route. And so you could design a new lock opcode on the Dogecoin side, which can only be unencumbered if you provide it with an Ethereum Merkle proof along with all these block headers before it. But then you'd also need to allow for a challenge timeout so that other people can provide heavier or alternate chains. So you quickly realize that this is not feasible, especially without a hard fork or a massive chain to Dogecoin. Then the other existing solution is what people call a federated peg. So this is something that RSK has actually implemented already. And it's relatively simple. So all it says is that on the Dogecoin chain, I send a transaction to some address. That address is a simple multi-sig wallet. So let's say it's controlled by 5 key holders. You send that transaction in. In the relay contract, that address is hard-coded in. So if someone provides a Merkle proof of someone having sent money to that transaction, mints you the WOW tokens. And then at any point, if you burn these tokens, you just kind of have to rely on those multi-sig holders to send you your money back. And you could pick these key holders to be reputable people in the space. And, they could be Ethereum Foundation, Consensus, Truebit, Dogecoin Core, like any number of things. But at the end of the day, it's a centralized solution, and you're relying on people to do things out of altruistically. So we started thinking, could we improve on it? And the first kind of interesting idea that we hit was we could use the flexibility of Ethereum. Since the other chain is Ethereum, we could really impact what's happening on the Dogecoin side. So what if you made these multi-sig key holders actually deposit stake into the Doge relay contract, right? So going forward through the peg is the same way. Send the Doge transaction, WOW tokens are minted. But then when you want to go back, you burn your WOW tokens, right? Then a timer starts ticking inside of this Doge relay contract. So it's like 100 blocks, 99 blocks, 98 blocks. And within that time, someone needs to provide a transaction Merkle proof that a Doge transaction was sent from this multi-sig to that address that just burned the coins. Otherwise, the multi-sig key holders get slashed. So you're kind of keeping them honest by using their Ethereum stake as collateral. And also, in addition to that, if anyone ever proves that a transaction was sent from this Doge multi-sig somewhere without a corresponding WOW token burn beforehand, you can also slash the operators, because basically they've gone rogue and they're spending the coins themselves. So then we started thinking about this. Is the multi-sig actually necessary? And the answer is no, because Well, there's first a problem in which any of these key holders could be punished, could lose their stake due to the misbehavior of other parties that they don't have any control over. So if 3 of the parties, decide to sign a transaction and send money to themselves, they could end up getting the other 2 slashed. Or if not all of them are up and this timer runs out, you could slash all of them. And it's actually a crypto economic scheme. So the security of it comes from the collateral that these people have in Ethereum in the Doge relay contract. So it's actually the same security if you change this to being one operator, a single Doge address. So this kind of makes the scheme more flexible. There's a Doge relay contract on the Ethereum side. Anyone can really deposit some ETH into it, and in that function call, provide a Doge address, and basically say that I'm becoming an operator from now on, right? This is my address, this is how much collateral I have, and from then on, anyone who sends money to that Doge address will move through that bridge, and then when they burn their coins, that timer starts ticking specific to that address, and this user is supposed to send them their money. And why would people do this? Because they can receive fees in return for allowing people to use their bridge. So it's another way to get a yield on your staking. Then we run into some issues. So how much ETH collateral do you actually need per Doge that has traveled through and been minted as well? Because if you think about it, if the value of Doge increases relative to ETH, then this collateral is no longer enough. So then the person who just had the Dogecoins and sitting in their UTXO will just spend them and be like, to hell with my stake, you can burn it, because now I've actually made money. So how do you deal with that issue? And the second point is, how long do these bridges stay open? Because if I become an operator for a bridge, and then someone mints WOW tokens through me, am I able to close my bridge? What kind of guarantees do I have there? Do I just have to give up my coins forever? And that constraint on its own will prevent most people from participating. So that's kind of one of the core issues. So now we're kind of, the next 3 slides are 3 different kind of ideas we have for moving forward. And this is open research. So if you have any ideas, please come and talk to us. So the first idea is kind of a natural progression. Allow this operator to state a bridge expiry time when they create it. So they make the call, they provide some ETH stake, they provide their Doge address, but they also provide a block number at which the bridge is no longer open. And the contract would enforce some minimum blocks in the future that you need to set, so the bridge is actually real. So then, yeah, they create the bridge, people send them money, they go through. What happens if the expiry date is hit? That means that the person gets their ETH stake back, and since they got their stake back, they can move the Doge to their own address, and the bridge has basically effectively closed. That means that the WOW tokens that were minted through this no longer have a real bridge or a real Doge backing them, so they become worthless. So that's the big, so if you think about that, what that means is different WOW tokens that were generated through different bridges have different lifetimes. They expire at different times. And a WOW token that is going to exist for longer before it becomes useless is more valuable. So the WOW tokens actually become non-fungible, which is kind of a problem. On the other hand, you could imagine that, sure, it's not ideal if ERC20 tokens are not fungible, but maybe this isn't a real ERC20 token, right? It was generated by another bridge. You could kind of add an extra method or something which tells you how long the token has to live, and contracts that are accepting it can just do a quick check and be like, is this token going to live long enough before I return it back to the user? So there are ways that you could make this work, but it's not ideal. This is the first proposal. The second proposal, like totally different axis of thinking. So the operator, I want to operate a bridge. I stake some ETH into the relay contract, And at that time, I'm already required to have enough Doge sitting in that address. So I provide both the Doge and the ETH stake. And I immediately mint an equal number of WOW tokens that I just contain. I just hold all of them. And then I can go to the market and sell these WOW tokens to other people. So WOW tokens get created. They get dispersed around the market. And then at any point, if I want to close the bridge, I need to buy back enough of these WOW tokens and burn them to be able to close my bridge. So the pro here is that the WOW tokens are fungible. They no longer have timelines attached to them. It's up to the bridge operator to buy them back whenever they want to close the bridge and burn them. The negative is that this is not really a bridge, because you can't just simply send Doge and receive WOW tokens. You actually need to send Doge and have an ETH stake to then create WOW tokens. So it has a higher barrier to entry. And what if the operator actually can't buy back all the WOW that they need on the market when the time comes that they want to close it? Has its own problems. The third one, which is kind of a more recent idea, and it's not fully fleshed out, is to create different tiers of exchange rates. And this is, it's getting complicated. Create different tiers of exchange rates at which WOW tokens could be collateralized by the ETH. So when you want to cross one of these bridges, you actually state what ratio of collateral you require. And so that's one part of the design. The other part is that operators basically, when you open a bridge, the only parameter is when you opened it. So it's first in, first out. And then when someone owning those WOW tokens wants to burn them and receive the Doge back, the operator whose bridge is the oldest is responsible for making that transaction. So that means the sooner you created the bridge, the sooner you get your money out, and the more fees you collect, because all of those transactions go through you originally till your capacity is filled up. So this, again, skips the bridge lifetime problem, kind of steps to the side, because as an operator, you're making a conscious decision to open a bridge, and you know where you stand in the queue and what the volumes are that you need before you can get out. And it also puts the onus of thinking about exchange rates to the WOW token holders. So if they have a WOW that's collateralized by ETH at a 1 to 0.1 ratio, they know that if the exchange rate changes beyond this, that the operator won't return their coins anymore. They'll just take the UTXO. And what that means is that all of the WOW minted at this exchange rate basically becomes useless. So it's similar to that original design. It's non-fungible between these different tiers of exchange rates, but it's fungible within the tiers. And yeah, so ongoing research, like I said, different ideas. The design space is kind of restricted, but that's why I think it's cool to talk about something like this here, where there's a lot of people who've thought about these things. So it's an interesting project. We can try different things. And I want to give a shout out to Sunny and Jim Posen, who've been external collaborators, and a bunch of others that we're talking to and giving us ideas. And yeah, that's it. Any questions?